Imagine holding a gemstone in your hand. At first, it's a cool ocean blue, but as your fingers warm it, something impossible happens. The stone slowly turns green, then yellow, then in some cases deep red. No lights, no chemicals, no tricks, just your body heat. For years, people believed gemstones were static, frozen in beauty, unchanged for millions of years. But this one breaks that rule completely, and once you understand how it works, you'll never look at gemstones the same way again. This is the story of thermochromic gemstones, and the most famous among them. Most people first encounter this phenomenon through a gem called discovered in the 1800s. Alexandrite became famous for changing color between daylight and candlelight. But scientists later realized something even more shocking. Temperature also plays a role. When warmed by the human body, some alexandrites subtly shift color, not dramatically like a mood ring, but enough to be visible under controlled conditions. That discovery opened the door to a much stranger world, because alexandrite isn't the only stone that reacts to heat. In the late 20th century, researchers identified vanadium-based crystals and synthetic sapphires that display extreme thermochromism. When cool, they appear blue or purple. When warmed by skin contact, their internal crystal lattice shifts just enough to change how light moves through the stone. The result, a visible color change triggered by you. Here's what's happening. Inside these gems are trace elements like vanadium or chromium. These atoms absorb light differently depending on how tightly the crystal lattice is vibrating. When your body heat warms the stone, the lattice expands slightly, just fractions of a nanometer, but it's enough to alter which wavelengths of light are reflected back to your eyes. That microscopic change creates a macroscopic effect. Color transformation. This is why the gem feels almost alive. But here's where it gets even crazier. Some stones don't just change once they shift through multiple colors depending on temperature. Cool room blue, warm fingers. Green, hot environment, yellow or red. The gemstone becomes a natural temperature sensor, without electronics, batteries, or software. In fact, scientists studied these gems to help design early thermal sensors and color-changing materials used in aerospace and medical fields. The gemstone world quietly contributed to modern tech, and most people never noticed. Now let's talk about the stone that made this phenomenon famous among collectors. Zultanite, a rare gemstone mined, primarily in Turkey, doesn't just change with light, it reacts to warmth as well. When held, its color deepens and shifts faster than expected, especially under natural lighting. Jewelers noticed customers experiencing different colors depending on how long they wore it. At first, they thought it was imagination. It wasn't. Body heat was influencing the stone's appearance, and this created a problem. Because gemstones that change color are hard to standardize. Their value depends on lighting, temperature, and even who's wearing them. Two people could look at the same gem and see two different colors, and that makes pricing controversial. Some gem dealers quietly avoid these stones. Others embrace them and sell them as living gems. But not all thermochromic gemstones are natural. Scientists eventually learned how to engineer the effect. Synthetic crystals were developed that exaggerate color change dramatically. Some of these stones shift color within seconds of touching skin. Blue to pink, purple to green. Almost instantly, they look fake, but they're real crystals. This is where confusion begins. Many people think these stones are just mood rings, but mood rings rely on liquid crystals sandwiched under glass. Thermochromic gemstones are solid, crystalline materials with internal atomic shifts. No liquid, no coating, no gimmick, which raises a scary question. If a gemstone can react to your body heat, what else could it react to? Pressure, radiation, chemical exposure. That question is exactly why defense researchers and material scientists became interested. These stones proved that passive materials could respond dynamically to their environment, something we now see in smart materials and adaptive tech. So why don't jewelers talk about this more? Because it complicates everything. Color grading becomes subjective. Certification gets harder. Returns increase. A gem that looks blue in the showroom might look green on your finger and red under studio lights. Some buyers love this. Others feel misled. And yet demand is growing. Collectors want stones that feel personal, unique, reactive, something no one else can fully replicate. A gemstone that responds to you is the ultimate luxury flex. And here's the wildest part. Two people holding the same gemstone at the same time can see different colors, different body temperatures, different skin contact, different perception. One stone, multiple realities. So the next time someone tells you gemstones are just pretty rocks, remember this one. A stone that listens to your body, a crystal that changes because you exist. And once you see it happen in real life, you'll never forget it.